All right, so we're on 2C.3, logarithmic functions. Our goal here is to just take more time to understand domain, practicing that, and breaking it down. Concavity. Did y'all see the extra kind of reminder for concavity I posted? I felt like maybe reading it that way and seeing that chart can help you understand a little bit better when it's concaved up, when it's concave down, and what it means. Yeah, but also whether it's increasing or decreasing. So yeah, your rate of change. So if it's shaped concaved up a certain way, what is your rate of change doing? If it's concaved up another way, what is your rate of change doing? All right. So our goal is to make sure you're comfortable with identifying characteristics of a log function. Okay. So when you are identifying, this is going to be a non-calculator side of the test. You should be able to identify the x-intercept. That's because there is no y-intercept, right, in the parent function. The y-axis is your vertical asymptote. You should be able to tell me that when b is greater than 1, the function is increasing. When b is between 0 and 1, the function is decreasing. That the graph contains these points. Whatever your b value is where your 1 is. And then the negative, where 1b is going to be your negative 1. And the graph is smooth and continuous. Okay, there is no sharp corners or gaps. No gaps, holes, or asymptotes. All right, so looking at what we have here, we're going to talk about, without graphing, what is the domain of each one of these log functions, okay? Oh, I put them out while you were taking the quiz. You got them. Right there. Did I put out the wrong note? I put out the right notes, right? Oh, okay. I was like, I thought I did. Oh, no, you didn't. All right. The assignment that I do till next Wednesday. Oh, yes, yeah. All right. So things that we need to know about looking at it without a calculator. So first off, when I have x plus 5 cannot be negative. Okay. So the log, this cannot be negative. I changed the setting for my pen to automatically learn. So x plus 5 can't be negative. X plus 5. No, the base is just the rate that it's changing. Because you have a vertical asymptote that prevents you from going into negative x's, right? Negative values. So your vertical, so now your vertical asymptote have shifted. Okay, there we go. Yeah, so if I have this set up where it says that x plus 5 has to be greater than 0, this has to be greater than 0, right? X can be a negative because of this shift. But this itself, what's inside the parentheses, has to be positive, has to be greater than 0. Okay, so when I am solving this, I am doing what? What do I need to do to solve? Minus 5. When I minus 5, what do I get my domain to be? X has to be greater than negative 5. So my domain is negative 5 to infinity. Okay. All right. So next we have here log base 3 of 1 minus x over 1 plus x. Okay. So again, inside my argument has to be greater than 0. It has to be positive. So 1 minus x over 1 plus x has to be greater than 0.
The domain of negative 5, would that be a bracket or would that be a parentheses?
It's a parentheses because it's a vertical asymptote there. Remember, that was one of the things we need to remember, that logs have vertical asymptotes, okay? And then when they shift, those vertical asymptotes are also shifting horizontally. Okay, so next up we have log base 3 of 1 minus x. We've set it up, and we need to make sure that this is greater than 0. Okay, this is a little bit of a tricky one, being that how can I say this?
So it can be one or.
Yeah, it can't be exactly. I was like, you also have restrictions. You can't be one, you can't be -1. Like there's just a lot of things, right? So you have to account for your denominator and you have to account for your numerator because it has to be greater than 0. So when you're thinking about this, right off the bat, we know that x cannot equal what? -1. And then in order to be greater than 0, x cannot equal 1. Does that make sense? Because 1 minus 1 would make 0 in the numerator, and -1 plus 1 would make 0 in the denominator. So therefore, my domain is x is sandwiched in between that. So it's from -1, not equal. You didn't see that. You saw nothing.
-1 and 1.
Ones, no, they are asterisks. That would be my domain. It would be parenthesis, -1 to +1.
But like a very small section of a function.
It's only a very piece, it's a sandwich. Because I had to accommodate the radical and I had to accommodate the log rules. All right, absolute value of x minus 2. Does anyone remember how to solve an absolute value? Okay. When you're solving absolute value, you solve it as it is, and then you solve it as its opposite. Do you remember that? So we would solve it as x minus 2 is greater than 0, and then we would solve it as the opposite of this, which is -x plus 2 is greater than 0. And that's because it's absolute value. It could come out, it could have been negative or positive to produce the result. All right, so what are my x's? X is greater than 2. And what happens here? It's x is less than what? If I subtract the 2, but isn't it less than?
Yeah, it's less.
Because when you divide by a negative, what happens? You have to switch the sign. You remember that? You got to flip that switch. So if you divide or multiply by a negative, we got to flip the switch. And in this case, we divide by a -1. Okay. So this tells me that it's going away from that. So there is a discontinuity at 2, right? A whole or an asymptote that's forcing it to go the opposite direction, correct? So therefore, our equation is from -infinity to, our domain is -infinity to 2 and 2 to infinity. I go to the left of 2 and to the right of 2, but I do not touch 2. It's a discontinuity, so it's parentheses. It's a point where I'm not continuous. Okay?
How would you write that on the graph? Or how would you graph that?
You just graph log, and it would do it itself.
You have to, you know, they graph the absolute value.
Yeah, you just graph what the log equation is. He said, how would you graph that?
Okay, there's a button.
Yeah, you do graph, you do log, base 1/2, math, number.
Yeah.
Num, sorry. Math, num. Num. Okay. All right. Up next. So the graph of logs are given and they want us to match based on what's happening. The characteristics. So when we look at it, we're going to first identify whether it's a growth or a decay. That's just going to help you narrow it down. Does that make sense? So it's a growth if your log is positive, right? So my log is positive, it's a growth. It's also a growth. It can also be a decay if my log, if the argument is negative. Does that make sense? All right, so f of x, is it a growth or a decay? So this is a growth. So that means it could be either only.
Oh, we're matching them?
Yeah.
Oh,
It can be C, No, we're labeling. I was gonna go through and say growth or decay first. Is that cool? G of X, is it a growth or a decay? It's a decay. The argument is negative. Perfect. You know, I promise y'all, my pen only does that for you guys. Okay. The argument is what's inside of the parentheses after the base. Growth or decay? Decay. The log is negative.
So if any part of it is negative, it's a decay.
No, I'm gonna show you right here. So on this one, you would think it's a decay, but what is your base? 1/2. Your base is less than 1, so it does the opposite, which makes it a makes it a growth. So when your base is, so let's go back to this right here. So if I was here at 2, at log base 2, and it was, that's a growth. If I changed it from log base 2 to log base 1/2, it's going to flip this. So now it's already a, let's look at it graphically. Second plus 7, 1, 2. I'm going to go to y equals. And we'll do alpha window 5. So log base 2 of x looks like this. So here's your log base 2 of x. A growth, right? All right. Now I'm going to go back and do log base 2 of 1/2. So alpha window 5. I'm going to do 1/2. And was it negative x? Well, no, I don't want the negative yet. So this 1/2 x looks like it's already decaying, right? And then I'm now making my x negative, which now means I'm reflecting over the y-axis, which is now going to make it a increase. Do we see that? So that is why. Go back. So when we make this negative x, you'll see that it's now going to reflect over the y-axis.
Let me see.
So when it reflects over the y-axis, it does this.
Yeah.
It's D.
Oh, no, it's D.
It's D. Okay, so that's the difference. Other ways to look and determine what's happening is just also where your values are. So I know that that this f of x is c. That's because at 2, I'm equal to 1. Because your b is going to be your value. So this is f of x. Okay. And by default, my other growth had to be a D, right? Now we're between our 2 decays. So looking at our decays, exactly, it was reflected. So it had to be reflected. So therefore, this is my h of x, and then g of x. And that, I wrote those backwards. This is not, what's wrong? This is g, and that's h.
So if you're trying to write the first one in exponential, it would be 2.
This is a reflection over the x, and this is a reflection over the y. I'm sorry.
If you're trying to write the first one or any of them in exponential, it would be like 2 to the power of y or f of x equals x.
Yes.
Okay.
Yes. Good job for recalling that. That is what we're doing in pre-V algebra 2 right now. The converting. Okay. So it says based on your findings, which graph above would also be correct for y equals log base 1/2 of x? Who do you think I can get that? So based on what I have here. So this was the log 1/2 of negative x, right? So positive would be on the other side. It would be b. It would match h of x, right? So h of x, which equals negative log base 2 of x, is equivalent to log 1/2 of x. And the reason being is because of how it turns out as an exponential. So as an exponential, that negative would become part of your y, right? Because you multiply the other side by y, so you end up with 2 to the y equals your x. Same thing here. You would have your 1/2 and then be left without an, oh, I left, draw my negative. You have 1/2 to the y equals x. And what does a negative exponent means? It goes in the denominator, which is why they're the same. All right, so I got to make a, well, this is gonna be a long video I got to make by myself. It's a lot of talking.